Okay, we want to compute this integral, and we're going to use these integration formulas over here. Let's match it up. See how it matches with that one because that one has the square root. But we're going to match with this one. And notice we have to have something squared minus something squared inside the square root on the bottom. So I've got to rewrite the integral we have to look like that one. Then I can use the formula. That's how you use formulas in math and science. You make things match up. So the square root in the bottom, I can write this as 1 squared minus 2x squared. See what I did there? Because 2x, the whole thing squared, goes back to 4x squared. Why? And 1 squared, of course, is 1. So why am I doing that? Because I'm trying to make it look like this one, specifically that right there. Something squared minus something squared. Got to make it match. So you can tell by looking at that that this is the a, right? The a is 1, and the u is 2x, right? U squared a squared minus u squared. So the u is 2x, the a is 1. So, okay, so what? Well, if u is 2x, then we'll do the derivative du dx. What's the derivative of that? It's just going to be 2, right? Because the 1 power just comes down, subtract 1, the x is gone. You know, the derivative of 2x is just 2. And then multiply both sides by dx. Boom. So du is 2 dx. Right? du is 2 dx. I've got to replace that dx right there. So multiply both sides by a half to find out, boom, that dx is a half du. That means wherever we see dx, we can replace with a half du. So this dx right here, I'm going to replace it with a half du, like that. So this integral becomes now the integral of 1 over the square root of 1 squared minus u squared, and then a half du, right? That's where the dx was. The half du goes there, like that. Now, let's take that half and just move it to the front because, multiplied numbers can just go in the front. So now we match the look of that. Here's our A. Our A is 1. And we know what our U is. It's 2x. We have it over here. So therefore, we know what the answer is. The answer is and once you make it match, once you make it look the same, see how this matches this. The A is 1 and the U, we already know over here, is 2x. So the answer is that the half's still in the front, by the way. A half. Well, here, let's do it vertically. That'd probably be easier to say. So in other words, what I'm saying is I'm saying this part, this integral thing, the half is still sitting there in the front times, and this integral that I just circled is the same as that, so it equals this. It equals arc sine of u over a, which is what? It's a half arc sine. What is u? U is 2x. What is a? A is 1. 2x over 1. Or just 2x, and then, of course, plus a constant. And that's the answer right there. They wrote sine inverse instead of arc sine, but same thing. They wrote 2x instead of 2x over 1. Same thing. So one more time. Whenever you're using math and science formulas, you basically have to take what you're given and make it look like the formula. I call that plastic surgery. We're removing the wrinkles. We got to give it a new look so that it matches our formula and so we can use our formula. So you're looking, okay, well, I got to make this match that. How do you do it? Well, you can just look at the form. It's something squared minus something squared. So I had to write 1 and 4x squared as 1 squared and 2x squared. And that told me my u is right there. It's the 2x, and then take the derivative. Du dx is 2. Move the dx over. Multiply by the half. So dx is a half du. So that dx right there became a half du. And I rewrote the integral like we learned to do with u subs. And the half came to the front. And the bottom is 1 squared minus u squared. So now this looks exactly like that, where the a is 1 and the u is 2x. So then you can use the formula. Once you make your thing match any math or science formula, then you can use the formula. The half's just sitting in the front, but this integral piece that I circled matches this integral piece. And so the answer is arc sine or sine inverse of u over a, which is 2x over 1 plus the constant, and we're done.